This video covers section 6.7, Modeling and Solving Problems with Quadratic Equations, Objective 1. Model and solve problems involving quadratic equations. In example 1, we have a model rocket. It's fired straight up from the ground. The height, h, of the rocket in feet at any time t in seconds can be modeled by the equation h equals negative 16t squared plus 160t. So we take this rocket, shoot straight up in the air, comes back down, and we can measure the height at any given time. And we want to know, when will the rocket be 384 feet from the ground? So letter A, we want to know when, or that is, we want to know t, so that the height is 384. So we set 384 equal to negative 16t squared plus 160t. And there's our quadratic equation. We solve this by getting 0 on one side. We get 0 equals negative 16t squared plus 160t minus 384. We need to factor out the greatest common factor. These numbers are kind of big, so this seems rather challenging. The question is, does 16 go into 384? Because 16 goes into 160, but what about 384? 16 goes into 38 twice. The remainder is 6, that's 64, so it goes in there 24 times. So the GCF that we're going to factor out is going to be negative 16. That gives us t squared minus 10t, dividing everything by negative 16, and gives us plus 24. T squared minus 10t plus 24. Now we factor that, negative 16 times t minus 6 times t minus 4. We use the zero product property and set each of our factors equal to 0. Now negative 16 isn't 0, so we disregard that one. And so we get t minus 6 is 0, or t minus 4 is equal to 0. So it looks like 6 seconds and 4 seconds. The rocket will be 384 feet from the ground. So it goes up, and after 6 seconds, after 4 seconds, it first attains the 384 feet, and then it comes up to the top and then right back down, and so then 6 seconds later, it hits that same 384 feet. If we want to know when it will strike the ground, letter B, we want to know t so that the height is 0 on the ground. So this time we set h equal to 0, and we get 0 equals negative 16t squared plus 160t. The greatest common factor is negative 16t, and that's going to leave us with t minus 10. We set the two factors equal to each other. Negative 16t is 0, or t minus 10 is 0. If negative 16t is 0, we divide by negative 16 and we get t equals 0. If t minus 10 is 0, we add 10 and we get t equals 10. So we know that it was at the ground at 0 seconds because that's where we shot it from. So it's 10 seconds later. After 10 seconds, the rocket strikes the ground. Example 2, the length of a rectangular room is 1 foot less than twice the width. 1 foot less than twice the width. The length is 2w minus 1, and the width is w. Find the dimensions of the room if the area of the room is 45 square feet. Area is length times width. And if the area is 45, the length is 2 times the width minus 1, or 1 less than twice the width, and the width is w. So we have the area is the length times the width, and that makes a quadratic equation because when we distribute the w across, we get 2w squared minus w. 2w times w is 2w squared, and when you have a squared term, it's a quadratic equation. We solve this by getting 0 on one side. We achieve that by subtracting 45 from both sides. And so now we have to solve this by factoring. And so I'm going to do this one by the AC method. I'm going to take A, which is 2, and C, which is negative 15, and take A times C, which is negative 90. 2 times negative 4 is negative 90. And it has to add up to negative 1. So the two numbers that do it are negative 10 and positive 1. Sorry, negative 10 and positive 9 is what I meant to say. And so we replace the negative w with negative 10w plus 9w minus 45. So from the first pair of numbers, we factor out a 2w, and that leaves us with w minus 5. From the second pair, we factor out a 9, and that leaves us with w minus 5. We factor out the w minus 5 to the right-hand side, and we're left with 2w plus 9. Now that we have the factors, we set each of our factors equal to 0. The first one says 2w is negative 9, which makes w equal to negative 9 over 2. Second one says w minus 5 is 0, or w equals 5. So either w is negative 9 halves or w is 5. But when talking about widths of a rectangle, we never say that a width is negative. So we cross that one out, and we just use the width is 5. And if the width is 5, the length is 1 less than twice the width. And that makes 2 times 5, which is 10, minus 1, which is 9. So the dimensions are 5 by 9. 5 feet by 9 feet. 5 times 9 is 45. And 1 less than twice 5 is 9. So those are the called for dimensions. This leads us to your practice problem. The base of a triangle, that's the base, is 3 meters shorter than its height. Its height is given as this one. What are the height and base of the triangle if its area is 44 square meters? Remember that the area of a triangle is 1/2 its base times its height. So I encourage you to press pause in your video and try to work this out, and come back and press play when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. The base of our triangle is 3 meters shorter than its height. This is the height, and the base is 3 meters shorter. The area is 44 square meters. So the area is 44. The base is h minus 3, and the height is h. In order to solve this, it's a good idea to multiply both sides of this equation by 2. 2 times 44, 2 times 1/2, times h minus 3 times h. I wanted to get rid of that 2 right there, so we're left with h minus 3 times h. 2 times 44 is 88. So I have 88 is equal to h squared minus 3h. So we solve this by getting 0 on one side. We subtract 88 from both sides, and we have 0 equals h squared minus 3h minus 88. We solve that by factoring. The product of two numbers, it's negative 88. That adds to negative 3. Negative 11 and 8 are those two numbers. So this factor says h minus 11 times h plus 8. We set each of those factors equal to 0, and we get the first one says h is 11, and the second one says h is negative 8. We set h minus 11 equal to 0, and we set h plus 8 equal to 0. So 11 or negative 8. But remember, heights and distances, they can't be negative. So we cross those out, and we say that the height, h is 11 meters, and the base of this is 3 less than the height, or 3 shorter. And so that's 11 minus 3, which is 8. So the height is 11, and the base is 8 meters. And this concludes the video for section 6.7, Modeling and Solving Problems with Quadratic Equations, Objective 1, Model and Solve Problems Involving Quadratic Equations.